and we're going to show you a few concepts about physics. Right now, we have group members, me, Fred Okafor,
Fuad, Azemina,
and we have two other members, Mohammed and Shahryar. They're the editing technical members, so they will contribute as well. But anyway, I'm going to tell you what we're doing today. We're going to do forces and with physics, including the longboard here. And the first thing we're going to do is we're going to show you how work is done, and that's equal to force times distance. Second, we're going to show you how friction in the bearings can actually increase the speed of the board. Woo! Having some fun with this longboard. Oh, yoo-hoo! Whoa, what's going on? Hey, keep going. Like the engine go. Slow it down. Okay. Something's going on here. What in tarnation? It looks like my board just stopped. Why? I don't get it. Physics gods, tell me, why did my board stop? Wait, what is that? Dr. Storm, what is that? Oh, I get it now. He told me friction. Friction is the reason why my board stopped. And I actually remember now. Friction is a force opposing the motion you're going. If I'm going in that direction, friction's going that direction, which means this board is going to come to a stop at some point. Just like all moving objects against friction, friction is opposing force against the force you're going towards. So, if I was to keep on moving, let's say I pedal again, friction would eventually stop me unless I keep on applying a force. Friction will stop you, and that's the force that opposes, movement.
On skateboarding. With this skateboard right here, there are 4 wheels, and within these 4 wheels are bearings, which you can see in the red. So basically what the bearing does is it helps reduce the friction between the wheel and the axle so that anytime you spin it, you can go longer distances without stopping. So if you add lubricant anywhere around the wheel, it will cause you to even go longer distances without it slowing down. So that's how friction plays a major role in skateboarding.
Again, we're going to talk about another concept, work. Work is equal to force times distance, okay? And in order to do work, you must travel a distance in the direction of force, okay? So, let's say I apply a force this way. I did work on the longboard, yes. Because the force I applied, the work I'm doing are in that direction. But let's say I just put my foot on the board and I apply a weight on the board. Okay, I'm applying a force, weight. Am I actually doing work though on the board? No, I'm not, because right now the board is actually at rest. So that is work, and also what I talked about earlier is friction. And those two together are some ideal physics categories to know about.
Now I'm going to explain how work works. Now basically this object right here, which is a skateboard, isn't going to move unless the force is acted upon it. Now that force is going to be me and my leg pushing it. So the way you can calculate that is by having work equals force times the distance applied to it. So the distance is going to be from A to B, and the force being my leg pushing it. So in this case, when I push it, I'm staying stationary. So the one that's doing the work is the skateboard and not me. And that's how you can calculate work, is by getting the force, getting the information for that, and getting the distance from A to B and calculating that by multiplying. And that's how you get work. Now I'm going to explain force, mass, and acceleration. Acceleration depends on the force and the direction that it's applied to. If you double the force, you double the acceleration. But mass is also included in the equation. So if you double the mass and keep the same force, you half the acceleration to the equation that had half the mass. Now you can calculate this by having force equals mass times acceleration. Force being in newtons, mass being in kilograms, and acceleration being measured in meters per second squared. For example, if the force was 35 newtons and the weight or the mass was 100 kilograms, you do that calculation and you would get 0.35 meters per second as the acceleration.